question about Math 3C, Probability and Statistics at UCLA. Here's our video response.
Hey guys, so thanks for coming out to the review. So as promised, two things. One, thanks to Edgar, he reminded me I forgot to go over multinomial. So let's do this really quickly. And I'm going to do two things with this. First, I'm just playing like what it means, and then after we get through that, we'll actually apply it to a problem. Okay? So, best example that I think, let's just start with butt-headed. Okay? And I'll spell it with two D's just to make a point. So, it's actually a throwback to what we did in the first part of the review. Remember when we talked about the whole thing, combinations, things like that? This is another variation of those sorts of things. Okay? So, let's see what we can do. First off, if I'm doing butt-headed, for example, remember when we did permutations? We definitely know how to work with those. So let's pretend like this is a permutation. Go with what we know. So if we go with what we know, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 guys, right? You're comfortable with this by now, right? So we have 11 guys. You want to place them in order. So we know 11 factorial, right? Because here order matters because I'm going from left to right. Okay, so no big deal. Okay, but this isn't quite right. Remember, all throughout the review, one of the big themes was repetition, right? Overcounting, things like that. We've done the same thing over here. So how do we overcount here? Well, first off, we pretended like every single one of these guys was different, right? But not all of them are different. So let's start with the T's here. So this was, for example, happy T and sad T, right? We pretended like these guys were different. So if we'd end up with this setup, butt-headed, exactly the same word, right? But the way we counted, it was different, smiley and frowny versus frowny and smiley. Do you guys agree with that? So again, I'm making a mistake. I'm counting it as if you can tell these two guys apart when you really can't. So how many ways did I mess up? So with this setup, I overcounted 2 times, this way and this way, because I could flip them in 2 different places. In an entirely different setup, I would still make the same mistake. Even if T were here, 1 T were here, 1 T were here, I still have 2 options, right? Either like this or like this. Do you guys agree? So if that's the case, you know how to fix this, right? Since we're overcounting twice, I would divide this by 2. But if I'm being a little more formulaic, maybe 2 factorial. Okay, now let's look at the E's. Same thing. So if I had E smiley and E frowny, right? And I reversed the order and had E frowny and E smiley, the way you've counted, or the way we've counted, right? We think that they're different things. So this setup is different from this one. But you know, looking at the letters, they're the same, or at least in terms of the words they spell, right? So again, same mistake. I want to correct it. I overcounted twice, here and here, so I need to divide it by 2. Okay? So now the final one. Let's look at D. So I have, for example, D1, 2, and 3. And say over here we have something like D3, 1, and 2. Okay? In this setup, does everyone agree? We counted this setup as being different from this because I moved the D's around. But if you actually look at the words, you can't tell the D's apart. So I've overcounted because this setup is the same as this. A little trickier this time. So imagine I have 3 D's out there. D's 1, 2, and 3. How many ways for a given fixed setup can I mess this up? How many ways can I overcount where I pretend like that these are different but they're actually the same? You know how to run this. This is 3 choices for where the first D goes. Let's say I place D, 3 here. 2 choices for the second D, let's say, so 3 choices, let's say D1. Okay? And then 1 choice for the final D, in this case it would be D2. And you know how to play this. This is 3 times 2 times 1. So again I've overcounted to fix it, but not divide by 3, but 3 factorial. Okay? Obviously 2 and 2 factorial are the same, but here you'll really notice a difference. Okay, so not too bad, right? This is multinomial.